So today's topic will be the air pollution. We will talk about uh, the different sources of conventional or criteria pollutants and describe the several hazardous air pollutants and their effects. We will also talk about the air pollutants and how do these air pollutants affect the climate and stratospheric ozone, and what are the ways that can air pollution affect the human health, and what policies and strategies do we have for reducing the air pollution. Also, at the end, we will be talking about that has the world air quality been getting better or worse, and why is it so? Starting with a case study from a great London smog. We all know that London was once a legendary for its fogs. So, in the days of Charles Dickens and Sherlock Holmes, there were darkened skies and blackened buildings saturated with soot from hundreds of thousands of coal burning fireplaces. So, all these statues, the blackened buildings that were saturated with that soot from hundreds of coal burning fireplaces were a fact of life. So, those Londoners had been accustomed to filthy air since the beginning of industrial revolution. In early December in 1952, there was a dense blanket of coal smoke and fog that settled on the city. So under normal conditions, what happens is that winds keep polluted air moving away from the city and out over the countryside. These winds occur broadly speaking because air near the Earth's surface is usually warmed by the sun heat ground, while the air aloft is cool. So the turbulences that develop as the warmed air rises and cool air sinks, and the turbulence tends to circulate those air pollutants away from their sources. But from time to time, there is an inversion develops. That's the as the name implies, an inversion, which means it occurs when layers of the air are out of order. So still that cold air settles near the ground that trapped by the warmer layers above. In 1952, there was a killer smog that came on suddenly on Friday, December 5. So home heaters and industrial furnaces were working in full force, pumping out that smoke on the cold winter day. During the afternoon, there was visibility was plummeted and traffic came to a stop as the drivers were blinded by that smoke and fog. Hundreds of cattle at the cattle market were the first to go. So, with lungs blackened by that soot that suffocated while standing in their pens. So, people could cover their faces and go indoors, but the soot soon reached inside the buildings. So, this is what we are talking about, the killer smog of 1952. Concerts were cancelled because of that blackened air in the halls, and books in the British Museum were tainted with that soot. So visibility fell to a foot in some places. The ill and elderly, especially were those with lung or heart ailments, and heavy smokers were the next to go. So hospitals were filled with victims of bronchitis, pneumonia, lung inflammations, and heart failure. Like the cattle in the market, the victims' lungs were clogged by that smoke and microscopic soot particles. Their lips turned blue and they asphyxiated due to lack of oxygen. Healthy people, they tried to stay indoors and keep quiet, but children were kept home from school so they would not get lost in the dark as much as because of the air quality. 4 days later, there was a change in weather that brought fresh winds into London and the inversion dissipated. The studies have been had been carried out that at least 4,700 deaths were attributed to this air pollution. These alarming death counts got the attention of politicians and public alike, and gradually they led to changes in expectations and practices. So the air quality in cities is frequently worse than we would like. So, extreme conditions like the killer smog we talked about are mainly the historical curiosities today. So, we now have the higher expectations for air pollution control, and we no longer find it acceptable, at least in principle, for private citizens or industries to emit those pollutants that cause the illness or death. But things today are nowhere near as bad as they were in London in 1952. So there was a case study about the Great London Smog, the killer smog that occurred in 1952 in London. So in this chapter, we will examine the major types and sources of those air pollutants. We will also consider certain policies and technology that can help us ensure that events like the smog of London does not happen in our country or in your town. Talking about the air pollution and health, clean air is something that we take for granted when we have it. But once the region's air pollution becomes severe, removing those pollutants presents an enormous challenge. Pollution comes in many forms. It may be smoke, haze, dust, odors, corrosive gases, noise, or some toxic compounds that are among our most widespread pollutants. Some pollutants, such as sulfur dioxide, they irritate our eyes and lungs. Fine particles, they penetrate deep into our lungs. The airborne metals, they enter our bloodstream when we breathe them, and then they damage the nervous and brain function. So worldwide, these air pollution emissions, they add up to 2 billion metric tons per year. Sometimes the health and environmental costs of air pollution are very shocking, as we talked about the London smog, the killer smog in 1952 that occurred in London. But most of the time, the costs are more subtle. So, chronic illnesses that result from low level ongoing exposure is likely to cause more deaths, and they may cause higher health care costs than the serious but infrequent deadly smog events. The Organization for Economic Cooperation and Development, they have projected that by 2050, the chronic exposure to pollutants will cause 3.6 million premature deaths every year. While the air quality is improving in many industrialized countries, the newly developing countries have growing pollution problems. In Xi'an, China, it has often has the particulate levels above 300 micrograms per metric cube of the 20 smoggiest cities in the world. It has been found that among the 20 smoggiest cities in the world, 16 are in China. China's tea dwellers are 4 to 6 times more likely than rural people to die of the lung cancer. In 1970, the Clean Air Act designated new air quality standards to be applied equally across the country for six major pollutants. These six major pollutants are referred to as conventional or the criteria pollutants, and these include the sulfur dioxide, nitrogen oxides, carbon monoxide, ozone, lead, and particulate matter. So, transportation and power plants are the dominant sources of most criteria pollutants. National ambient air quality standards designated the allowable levels of those pollutants in the ambient air. That's the air around us. When we talk about the sulfur dioxide, it is a colorless corrosive gas that damages both plants and animals. So once that sulfur dioxide is in the atmosphere, it can be oxidized to sulfur trioxide, which then reacts with water vapor or dissolves in water droplets to form the sulfuric acid. which is a major component of that acid rain. Talking about the nitrogen oxide are highly reactive gases formed when the heat of combustion it initiates the reactions between the atmospheric nitrogen and oxygen. The initial product that's formed is the nitric oxide, which oxidizes further in the atmosphere to nitrogen dioxide, which is a reddish brown gas that gives photochemical smog its distinctive color. Because these gases they convert readily from one form to another, the general term that's the nitrogen dioxide is used to describe these gases. Nitrogen oxides they combine with water to form the nitric acid. Talking about the third conventional pollutant or criteria pollutant is the carbon monoxide, which is less common but more dangerous than the principal form of atmospheric carbon or carbon dioxide. Carbon monoxide is a colorless or we can say odorless but highly toxic gas that's produced mainly by incomplete combustion of fuel. That means the coal, oil, charcoal, wood, or gas. Carbon monoxide it inhibits the respiration in animals by binding to the hemoglobin in blood. It has been found that in United States, two-thirds of the carbon dioxide emissions are created by internal combustion engines in transportation. Sometimes the land clearing fires and cooking fires, they are also major sources of carbon monoxide. About 90% of carbon monoxide in the air is consumed in photochemical reactions that produce the ozone. Talking about the four conventional or criteria pollutant, we have the ozone, which is important in the upper atmosphere while it shields us against the ultraviolet radiation from the sun. But at the ground level, ozone is a highly reactive oxidizing agent that damages the eyes, lungs, and some plant tissues, as well as the paint, rubber, and plastics. So, this ground level ozone is a secondary pollutant which is created by chemical reactions that are initiated by the solar energy. So, in general, we can say that pollutants that are created by these light initiated reactions they are known as photochemical oxidants. We have a variety of volatile organic compounds that interact with ozone to produce the photochemical oxidants in smog. Talking about the unconventional pollutants, the EPA, that's the Environmental Protection Agency, also monitors these unconventional pollutant compounds that are produced in less volume than the conventional pollutants that we talked about, but they are especially toxic or hazardous. So, among these unconventional pollutants are the asbestos, benzene, beryllium, mercury, PCBs, that's the polychlorinated biphenyls and vinyl chloride. In 2009, the Environmental Protection Agency they announced that it would add carbon dioxide and other greenhouse gases to its list of regulated pollutants. But this decision still remains controversial. Most of these are uncommon in nature or they have no natural resources. So, how do we actually define the pollution sources? Many pollutants that come from a point source, such as the smokestack, fugitive or non-point sources emissions are those that do not go through a smoke stack. Leaking valves, pipe joints contribute as much as 90% of hydrocarbons and volatile organic compounds that are emitted from the oil refineries or chemical plants, and increasingly from natural gas wells. The dust from mining or agriculture and building construction and demolition, they are also considered as fugitive emissions. If we talk about the primary pollutants, they are the substances that are harmful when released. The secondary pollutants become hazardous after their reaction in the air with other gases or substances in the air. The fugitive or non-point sources emissions are those that do not go through a smokestack. We already talked about that. Many of our most serious pollutants, they are fugitive emissions from photochemical or petrochemical facilities such as those in Baton Rouge, Louisiana. You can see here in the picture. So these are the fugitive emissions. Are the conventional pollutants abundant and serious? So we have talked about the sulfur dioxide, the nitrogen oxide, that how they are highly reactive gases that are formed when the heat of combustion initiates the reactions between that atmospheric nitrogen and oxygen. Sulfur dioxide, it affects both plants and animals. We talked about that sulfur dioxide concentrations and deaths during the London smog of 1952. The Environmental Protection Agency standard limit is that zero point zero 0.08 milligrams per metric cube. That's the dashed line here. Here in this picture, you can see the soybean leaf at the right. It was exposed to 2.1 milligram per metric cube sulfur dioxide for 24 hours. White patches you can see here, they show that their chlorophyll has been destroyed when they were exposed to that sulfur dioxide. How the ground level ozone forms. The heat of fuel combustion causes the nitrogen oxides to form from atmospheric nitrogen and oxygen. We already discussed that this nitrogen oxide then reacts with water to form nitric acid, which is a component of acid rain. So, in addition, the solar radiation can force the nitrogen oxide to release a free oxygen atom. This free oxygen atom joins to the atmospheric oxygen, creating the ozone. Fuel combustion also produces incompletely burned hydrocarbons, including the volatile organic compounds. So both ozone and volatile organic compounds, they contribute to photochemical oxidants in reactions that are activated by the sunlight. The volatile organic compounds shown here is benzene, which is a ring of 6 carbon atoms with a hydrogen from atom that's attached to each carbon. The main concerns are the most dangerous synthetic organic chemicals such as the benzene, toluene. We have certain formaldehydes, vinyl chloride, phenols, chloroform, trichloroethylene that are released by certain human activities. Principal sources are the incompletely burned fuels from vehicles or power plants, chemical plants, and petroleum refineries. It has been found that a wide array of these organic, that's the carbon based, or volatile, that's the evaporated chemicals, they are derived from industrial processes like refining of oil and gas, the plastics, and chemical manufacturing industries. Talking about the lead, which is the most abundantly produced metal air pollutant, it impairs the nerve and brain functions. It does this by binding to essential enzymes and cellular components and disabling them. The sources of lead contaminant are the industrial and mining processes that produce the lead, especially the smelting of metal ores, mining or burning of coal and municipal waste, in which is a trace element. Sometimes the burning of gasoline to which lead has been added might also act as a source of lead emission. Historically, the leaded gasoline was the main source of lead in United States, but leaded gas was phased out in 1980s. So since 1986 when the ban was enforced, children's average lead levels have dropped 90% and average IQs have risen 3 points. So, banning that leaded gasoline in the United States was one of the most successful pollution control measure in American history. Now we have 50 nations that have renounced that uh, leaded gasoline. The global economic benefit of this step is estimated to be more than $200 billion per year. Talking about the particulate matter material, which includes the dust, ash, soot, lint, smoke, pollens, spores, algal cells, or any other suspended materials like the aerosols. They are extremely minute particles or liquid droplets that are suspended in the air or included in this particulate material class. Particulates, they are often the most apparent from air pollution since they reduce the visibility and they leave dirty deposits on windows or painted surfaces and textiles. Breathable particles smaller than 2.5 micrometers, they are among the most dangerous of this group because they can damage the lung tissues. Certain asbestos fibers and cigarette smoke are among the most dangerous respirable particles in urban and indoor air because they are very carcinogenic. It has been found that these hazardous air pollutants they can cause cancer and nerve damage. So most of these chemicals are either metal compounds, chlorinated hydrocarbons, or volatile organic compounds. Gasoline vapor, solvents, and components of all plastics, they are the hazardous air pollutants that you may encounter on daily basis. Many hazardous air pollutants are emitted by chemical processing factories. We have that produce gasoline, plastics, or solvents, or pharmaceuticals, or other organic compounds. If we talk about the benzene, toluene, xylene, and other volatile organic compounds, they are among these. Dioxins, that's the carbon based compounds containing chlorine, they are released mainly by burning plastics or some medical waste that contain the chlorine. These persistent substances that remain in the ecosystem for long periods of time and accumulate in animal and human tissues. In 1986, the Congress established the Toxic Release Inventory, that is the TRI, to help inform communities about the toxic substances, how they can be produced, how they are produced, and how they can be handled in their area. The inventory that collects self-reported statistics from 23,000 factories or refineries or hard rock mines, power plants, and chemical manufacturers, they report on those toxin releases above certain minimum amounts and waste management methods for 667 toxic chemicals. The TRI, that's the Toxic Release Inventory, is widely considered the most comprehensive source of information about toxic pollution in the United States. Let's talk about the mercury. The airborne metals originate mainly from combustion of fuel, especially coal, which contains the traces of mercury, arsenium, cadmium, and other metals. They are all carcinogenic, as well as sulfur and other trace elements. Airborne mercury has received the special attention because it is widespread and persistent neurotoxin. That means it damages the brain and nerve system. Minute doses that can cause the nerve damage and other impairments, especially in young children and developing fetuses. It has been found that About 70% of airborne mercury is released by coal burning power plants. The metal ore smelting and waste combustion also produce certain airborne mercury and other metals, like the cadmium. About 75% of human exposure to mercury comes from eating fish. This is because the aquatic bacteria are mainly responsible for converting the airborne mercury into methyl mercury, a form that accumulates in living animal tissues. Canned tuna is a source of mercury, which is our dominant source of mercury, though, because it's a top predator fish that we eat in abundance. A 2009 report by United States Geological Survey found that mercury levels in Pacific Ocean tuna have risen 30% in 20 years. It has been found that increased coal burning, if continues to build new coal burning power plants, is understood to be the main cause of growing global mercury emissions in the Pacific. Freshwater fish also carry the risks like mercury contamination is the most common cause of impairment of US rivers and lakes, and 45 states have issued warnings against frequent consumption of caught fish. The US National Institute of Health estimates that between 300,000 and 600,000 of 4 million children born each year in the United States are exposed in the womb to mercury levels that can cause the diminished or developmental intelligence or impairments. Indoor air can be worse than the outdoor air, so because we have spent a considerable amount of effort and money to control the major outdoor air pollutants, but indoor air pollution is a growing concern. With increasing use of volatile organic compounds in carpets, furniture, cleaning products, paints, and other substances, the United States Environmental Protection Agency often finds high indoor concentrations of toxin toxic air pollutants. Compounds such as chloroform, benzene, carbon tetrachloride, formaldehyde, and styrene can be 70 times greater in the indoor air than outdoor air. Many homes have concentrations that would be illegal in the workplace because most of us now spend more time inside than outside. So we also have higher exposure to these pollutants. The indoor air pollutant cigarette smoking is without doubt the most important air contaminant in developed countries in terms of human health. In the less developed countries of Africa, Asia, and Latin America, where such organic fuels such as the firewood, charcoal, dried dung, and agricultural waste make up the majority of household energy, smoky, poorly ventilated heating and cooking fires are the worst sources of indoor air pollution. World Health Organization estimates that 3 billion people are affected by, especially the women and small children who spend long hours each day around the open fires in the less developed countries or unventilated stores in enclosed spaces. So, more than half of air pollution related deaths worldwide are thought to be caused by bad indoor air. Let's now talk about the air pollution and the climate. The air pollutants have important interactions with our climate. Pollutants cause climate change. We all know that carbon dioxide, methane, nitrous oxide, and halogen gases like the chlorofluorocarbons used in the refrigerants are the primary culprits. At the same time, warming temperatures they increase the ozone and photochemical oxidant concentrations in the air that we breathe, and normal atmospheric circulation distributing the pollutants around the globe. They expose the remote populations to industrial source pollutions. We all know that the air pollutants, they can travel the globe. Dust and fine aerosols, they can be carried great distances by the wind. Pollution from the industrial belt between the Great Lakes and the Ohio River Valley regularly contaminates the Canadian maritime provinces and sometimes can be traced as far as Ireland. Similarly, the dust storms from China's Gobei and Taklamakan deserts routinely close the schools, factories, and airports in Japan and Korea and often reach the western North America. In one particularly severe dust storm in 1998, it was found that chemical analysis showed that 75% of the particulate pollution in Seattle, Washington air came from China. Similarly, dust from North Africa or regularly crosses the Atlantic and contaminates the air in Florida and the Caribbean islands. So, this dust, which carries the pathogens and is thought to be the source of diseases attacking the Caribbean corals. Talking about the carbon dioxide and halogen, how they are the key greenhouse gases, the question of whether the Environmental Protection Agency should regulate these greenhouse gases was so contentious that it went to the Supreme Court in 2007. The court ruled that it was the Environmental Protection Agency's responsibility to limit these gases, the level of these gases, on the grounds that greenhouse gases endangered the public health and welfare. Carbon dioxide concentrations in atmosphere have been steadily increasing because of the human activities and they are now causing those global climate change. But it's not alone as a greenhouse gas. There are five other greenhouse gases like the methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride. These gases are far more potent greenhouse gases per molecule than carbon dioxide. And since the recent Supreme Court ruling, the EPA is charged with regulating emission of all these gases. Chlorofluorocarbons, they destroy the ozone in the stratosphere. Long range pollution transport and the chemical reactions of atmospheric gases and pollution produce the phenomenon known as the ozone hole, which means a thinning of ozone concentration in the stratosphere. This phenomenon was discovered in 1985, but it was probably been developing since at least 1960s. Chlorine-based aerosols such as the chlorofluorocarbons, hydrofluorocarbons, they are the principal agents of ozone depletion. Non-toxic, non-inflammable, chemically inert, long-lasting, and cheaply produced, these compounds were extremely useful as industrial gases, and these have been used in refrigerators, air conditioners, styrofoam insulation, aerosol spray cans for many years. From the 1930s and until 1980, the chlorofluorocarbons were used all over the world and widely spread through the atmosphere. So, because of this ozone depletion in the stratosphere, the ozone molecule is especially effective at absorbing the ultraviolet radiations as it enters the atmosphere from space. Ultraviolet radiations they damage the plant and animal cells, potentially causing mutations that might produce cancer. It has been found that 1% loss of ozone could result in about a million extra human skin cancers per year worldwide. So, excessive ultraviolet exposure could reduce the agriculture production and also disrupt the ecosystem. That's why the scientists now worry that high levels, the ultraviolet levels in Antarctica, could reduce the population of plankton, which are the tiny floating organisms that form the base of a food chain that include the fish, seals, penguins, or whales in the Antarctic seas. The discovery of the stratospheric ozone losses brought about a remarkable, quick international response. In 1987, an international meeting in Montreal, Canada, produced the Montreal Protocol. That's the first of several major international agreements on phasing out most uses of chlorofluorocarbons by 2000. It has been found that $500 million fund was established to assist poor countries in switching to non-chlorofluorocarbon technologies. Fortunately, the alternatives to chlorofluorocarbons for most uses already exists. The first substitutes are the hydrofluorocarbons, which release much less chlorine per molecule. So scientists now hope to eventually they develop the halogen-free molecules that work as well and are not more expensive than the chlorofluorocarbons. So what the scientists are actually doing, they are trying to find the alternatives for these chlorofluorocarbons. So there is evidence that chlorofluorocarbon ban is already having an effect. Chlorofluorocarbon production since 1988 and CFS are now being removed from the atmosphere more rapidly than they are being added. So, in 50 years or so, stratospheric ozone levels are expected to be back to the normal. The Montreal Protocol, which we already talked about, that was released in 1987, has also helped reduce the climate change because the chlorofluorocarbons and related compounds are such powerful and long lasting greenhouse gases. What are the different health effects of air pollution? So, this can mean as much as 5 to 10-year decrease in life expectancy if we live in the worst part of Los Angeles or Baltimore, for example. Because they are strong oxidizing, there are certain strong oxidizing agents like sulfates, nitrous oxide, ozone irritate, and damage the delicate tissues. We have certain fine suspended particulate materials that can penetrate deep into the lungs, causing the irritation, scarring, and even tumor growth. Heart stress, it also results from impaired lung functions. The carbon monoxide, if inhaled, it binds to the hemoglobin, reducing the oxygen flow to the brain. The other effects of air pollution are the headaches, dizziness, heart stress, result lead, which we already talked about. It binds to hemoglobin, damaging the critical neurons in the brain and resulting in mental and physical impairment and the developmental retardation. So, environmental effects of air pollution can involve similar, complex, and often gradually accumulating effects. There is certain acid deposition that results from the sulfate and nitrous oxide. The effects of air pollution on plants, especially the sulfuric acid deposition, have been known in industrial areas since 1850s. Acid deposition is now understood to affect the forests and croplands from the industrial centers. Rain is normally slightly acidic, that's the pH of the rain might be 5.6 because of the reactions of carbon dioxide and rainwater, which produced a mild carbonic acid. Industrial emission of sulfur dioxide, sulfates, and nitrous oxides or nitrogen oxide can acidify the rain. or fog, snow, and mist to pH of like 4 or sometimes lower than that. So, ongoing exposure to acid, fog, or snow, mist, and dew, they can cause permanent damage to plants, lakes, ecosystem, and also the buildings. The acid rain can also damage the forests because the high elevation forests are more severely affected by this acid precipitation. Mountain tops often have thin, often acidic soils under normal conditions with little ability to neutralize that acid rain or snow or mist. It has been found that buildings and monuments that show a clear damage, that's the we have a Parthenon in Athens, the Taj Mahal in Agra, the Colosseum in Rome, medieval cathedrals in Europe, and Washington Monument in Washington D.C. that are slowly dissolving and flaking away because of acidic fumes in the air. Acid deposition also speeds the corrosion of steel in reinforced concrete, weakening the buildings, roads, and bridges. Limestone, marble, and some kind of sandstone flakes and the crumbles. Atmospheric acids, especially the sulfuric and nitric acids, have almost eaten away the face of this medieval statue. You can see here. So, animal losses from air pollution damage to buildings and materials amount to be billions of dollars. That's why the Council on Environmental Quality estimates that US economic losses from architectural and property damage from air pollution it can amount to be about $10 billion every year. It has been found that in urban areas the pollution is most extreme when temperature inversions develop, concentrating dangerous levels of pollutants. This situation actually reverses the normal conditions. So, usually, what happens the air is warmed by the heat re emitted from the ground surface and it cools with elevation above the Earth's surface. So, warming air rises, mixing the atmospheric layers and helping pollution to disperse from its sources. When the cool, dense air it lies below a warmer or lighter layer, air remains stable and still, and pollutants accumulate near the ground, where they irritate our lungs and eyes. So, stable inversion conditions are usually created by rapid nighttime cooling, especially in a valley where the air movement is restricted. Los Angeles has ideal condition for inversions because mountains surround the city on three sides, reducing the wind movement, heavy traffic and industry. They create a supply of pollutants. Skies are generally clear at night, allowing rapid radiant heat loss, and the ground cools quickly. So surface air layers are cooled by contact with these cool ground surface, and also the upper layers they remain relatively warm and the inversion results. So as long as the atmosphere is still and stable, pollutants accumulate near the ground where they are produced and where we breathe them. There are certain heat islands and dust domes that occur in cities even without any inversion conditions. So, with their low albedo, concrete and brick surfaces in the cities, they absorb large amounts of solar energy. A lack of vegetation or water results in very slight evaporation instead because the available solar energy is turned into heat. So as a result, the temperatures in cities that are frequently like 3 to 5 degrees centigrade warmer than in the surrounding countryside condition is known as the urban heat island. We have certain tall buildings that can create convective updrafts that sweep away those pollutants into the air. Here in this picture, you can see the poor visibility over the Los Angeles because of the pollution. Talking about the smog and haze that reduce the visibility, we have only realized that pollution affects the rural areas as well as cities. Even supposedly pristine places, such as our national parks, they are suffering from air pollution. It has been found that Grand Canyon National Park, where maximum visibility used to be like 300 kilometers, is now so smoggy on some winter days that even visitors cannot see the opposite rim, only 20 kilometers across the canyon. So, mining operations, smelters, and power plants, they are the main culprits for this air pollution. People become accustomed to these conditions and they do not realize that the air once was clear. So, there has been a lot of studies that indicate that if all human made sources of air pollution were shut down, the air would be clear up in a few days. And there will be about 150-kilometer visibility nearly everywhere rather than 15 kilometer. Dilution is the solution to the pollution. This catchphrase has long categorized our main approach to air pollution. We have certain tall smokestacks that were built to send emissions far from the source where they became difficult to detect or trace their source. So, with the increasing global industrialization, it has been found that dilution is no longer an effective strategy. Particulate removal, it involves the filtering air emissions. Filters that trap the particulates in a mesh of cotton cloth or spun glass fibers or asbestos cellulose. So industrial air filters are generally giant bag cleaners. These bags can be huge, like 10 to 15-meter long and 2 to 3-meter wide. In power plants, the electrostatic precipitators can be used, or the most common particulate controls. Sulfur removal is important because sulfur oxides are among the most damaging of all air pollutants for human health, infrastructure, and ecosystem. Or we can say that switching from soft coal with a high sulfur content to low sulfur coal is the surest way to reduce the sulfur emission. But we have certain high sulfur coal that's often used for political reasons or because it's cheap. The sulfur can be extracted after combustion with the catalytic converters. What those catalytic converters do is that they oxidize or reduce the sulfur in effluent gas. Nitrous oxides can be reduced in both uh, internal combustion engines and the industrial boilers. For example, the control burning temperatures and oxygen flow to prevent the formation of nitrogen oxide. The catalytic converter that's on your car, it uses the platinum, palladium, and rhodium catalysts to remove up to 90% nitrogen dioxide, hydrocarbons, and carbon monoxide at the same time. Hydrocarbon controls mainly involve the complete combustion or the control of evaporation. Hydrocarbons and volatile organic compounds, they are produced by incomplete combustion of fuels or by solvent, plastic manufacturing, or printing and other industrial processes. So closed systems that prevent the escape of these fugitive gases can reduce many of these emissions. It has been found that an electrostatic precipitator, it can remove about 99% unburned particulates in the effluent or smoke that comes from the power plants. The electrodes transfer a static electric charge to dust and smoke particles, which then adhere to collector plates. The particles are then shaken off the plates and collected for reuse or dispersal, and we get a clean flue gas. In United States, the Clean Air Act of 1963 was the first national law for air and enforcement. Because of this approach, which was uneven and difficult to enforce, the act was largely rewritten in 1970, the Clean Air Act amendments. These amendments identify the criteria, that's that's the pollutants that we discussed earlier, the six pollutants. The 1970 rules also established primary standards that are intended to protect the human health and secondary standards to protect the materials, the crops, climate, visibility, and personal comfort. In 1990, amendments that included major changes in incentives as well as the rules for additional pollutants. So, among the major provisions were establishment of new control for ozone depleting chlorofluorocarbons. There were new rules for controlling emission of benzene, chloroform, and other hazardous air pollutants. And there was also a requirement that comprehensive federal and state standards can be set up for both industrial and transportation based sources of common pollutants. The 1990 amendment also provided the incentives and rules to support certain development of alternative fuels and technology. These amendments also established that the Environmental Protection Agency's right to fine violators of high air pollution standards. It was found that the 1990 revisions also created new incentives for pollution control. A serious shortcoming of this approach is that while trading has resulted in overall pollution reduction, there were some local or hotspots that remain where the owners have found it cheaper to pay someone else to reduce the pollution than to do it themselves. So, this has been the approach that was adopted for carbon dioxide and for mercury and other pollutants. So, for 23 of the largest USTs, the number of days each year in which air quality reached the hazard level is about 93% from a decade ago. So, of 97 metropolitan areas that failed to meet the clean air standards in 1980s, 41 are now in compliance. Most pollutants have declined sharply since the introduction of these Clean Air Act rules. Although the pollution persisted in the developing areas, the Mexico City is notorious for bad air because its pollution level exceeds the World Health Organization health standards 30-50 days per year, and more than half of all its children have lead levels in their blood, which is high enough to lower intelligence and retard the development. Mexico City, the major metropolitan areas of many developing countries, are growing at explosive rates to incredible sizes, and environmental quality is abysmal in many ways. China is making efforts to control the air and water pollution. Many of China's 400,000 factories have no air pollution controls. Experts estimate that home coal burners and factories emit about 10 million tons of soot and 15 million tons of sulfur dioxide annually, and that emission have increased rapidly over the past 20 years. Airborne particulates in Shenyang, China exceed World Health Organization standards on 347 days per year. So it's estimated that air pollution is responsible for 400,000 premature deaths every year in China. The high incidence of cancer in Shanghai is thought to be linked to that air pollution. Low income countries can control air pollution too. For example, Delhi in India was once considered one of the world's 10 most polluted cities. In 1990s, the catalytic converters were required for automobiles and unleaded gasoline and low sulfur diesel fuels were introduced. Like we already discussed that Delhi, which is a state in India, was once considered one of the world's 10 most polluted cities. So visibility, it was often less than 1 kilometer on smoggy days. Health experts, they warned that breathing Delhi's air was equivalent to smoking 2 packs of cigarettes per day. So you can imagine that how polluted the Delhi's air was. But the pollution level exceeds the World Health Organization standards by nearly 5 times. The biggest problem or biggest source was the vehicle emission, which contributed about 70% of air pollutions. That was followed by the industrial emission, 20%, and burning of garbage and firewood. But in 1990s, the catalytic converters were required for the automobiles and unleaded gasoline and low sulfur diesel fuel. They were introduced. So in 2000, private automobiles were required to meet the European standards. And 2002, more than 80,000 buses, auto rickshaws, and taxis were required to switch from liquid fuels to compressed natural gas in order to reduce that air pollution. By that act, the sulfur dioxide and carbon monoxide levels have dropped 80% and 70%. Also, the particulate emission dropped by about 50%. Residents report that air is dramatically clearer and healthier. So, concluding today's chapter, that's the air pollution. We talked about the air pollution, which is the most obvious and widespread type of pollution. We also talked about the health effects of these pollutants that include the respiratory diseases, birth defects, heart attacks, cancer, and developmental disabilities in children. Environmental impacts include the destruction of stratospheric ozone layer, that's the poisoning of forests and waters by acid rain and corrosion of building materials. We have also made encouraging progress in controlling air pollution. We talked about the state of Delhi in India, that how the progress has economic benefits as well as the health benefits. That was all about today's lecture. Thank you.